Okay, so in the sequence, so we can use operators like double hash. So this is called as consecutive repetition operator. This is like non-consecutive repetition operator. This is go-to repetition operator. Throughout keyword, within keyword, intersect, and or, all these are keywords. Okay. So in this way, you can write your sequence. These are examples. Clear everybody, like what is a sequence? And anybody having any doubts? If you are having any doubts, you can just ask me right now itself. Okay. So now we'll go deep into like what are these operators, what are these keywords. Okay, inside a sequence, these can be used, right? So what are those things? We'll go deep into it. So a double hashtag followed by a number or range specifies the delay from the current clock tick to the beginning of the sequence that follows. Okay, so it means like if you want to mention any delay or a range of a delay, you can use in assertions. In order to specify a delay or a range of delay, you have to use double hashtag operator. Okay, so this is double hash operator. So if you see request double hash 1 GNT, what happens is like when your request is high, this is request is one signal, your grant is another signal. Okay, so in between these two signals there was a relationship that when your request is high, after one clock cycle your grant should be high. Okay, so initially if you are writing request or if you are writing a signal like A, it will take by default the value of 1. Okay, if you are mentioning negation of request, then we are saying to that signal that it should be low. But here you are not mentioning any negation, so it was like high only. So it means when your request is 1, means when your request is high, after one clock cycle your grant should be high. What does this double hash 0 means? If you are mentioning double hash 0, so when your request is high, in the same clock cycle, your grant should also be high. And here you can also mention some delay. So when your request is high, between 0 to 3 clock cycles, grant will be asserted, like grant will be high after 0 to 3 clock cycles when request is asserted high. It means when your request signal is high, after 0 to 3 clock cycles, your grant will be high. Okay, clear like what is double hash operator does? Or you want me to explain in another way? See, these assertions and coverages are important topics. You have to understand it clearly. Okay. As I'm going past means it doesn't mean that you people should not get understand. So at the end of the day, my concern was you people have to understand it clearly. Whether you people understood or not, let me know. Otherwise, I'll just explain you in a different way also. I'll just make one thing. Okay. So this is your clock. Okay. And this is your request signal. Okay, your request signal at positive edge of a clock you are writing. So your request signal should be high. Okay, so it means like let us consider your request is high. This is your request signal. Okay, and according to the first condition, after 1 clock cycle delay, your grant should be high. It means when your request is high in this clock cycle, in the next clock cycle, your grant should be high. So it means like this is your grant signal. So at 1 clock cycle delay, after 1 clock cycle, your grant is high. Okay. So this is 1 clock cycle delay, right? This is 1 clock cycle delay from positive edge to negative edge. This is 1 clock cycle delay. So here at the first clock edge only your request is high. In the next clock edge, like double hash 1 means in the next clock edge your request is high. And for the second condition, like double hash 0, it means in the same clock cycle. What does it happens is like, so when your request is high, double hash 0, your grant should also be high, means in the same clock cycle, it also should be high. So this comes under, so this all three signals comes under your second thing, that is request double hash 0 grant. Whereas these three comes under request double hash 1 grant. So in the same way here, if you are mentioning any range, up to that range, your grant will be low, and after that range only your grant will be high. Now clear everybody?
Yes, ma'am.
Okay, so this is double hash operator, and we have dollar operator. So it means like, see here example, if you are mentioning like this, so here dollar represents like till end of your simulation. It doesn't represent infinity because you are not running your design infinity times, right? How many times you are running? So dollar here does not represent infinity, but dollar represent the maximum time or maximum number of times you were repeating or till end of your simulation. Okay. So it's like, it would be like an upper limit. So let's say you are running your design for 10 times. So in that 10 times, how much clock cycle you are getting up to that time, this the last clock cycle value, it will take it as dollar. Okay. It's not an infinite, but it represents the end of the simulation. So here, when your request is high, after 1 to dollar is your upper maximum limit. After that only grant should be high. So your grant should be high after this thing. So that's what here you have mentioned like this. Okay, means your grant signal will be high after 1 clock cycle. So up to how much time it should be high, you are mentioning that. It was like till end of the simulation. So this is used when something signal needs to be checked till end of simulation. We can use this dollar operation or dollar operator. Okay. If we don't know the upper limit value of a signal to be checked, then also you can use this dollar operator. Okay.
Ma'am, in previous slide for hash operator also we had same condition, right? Request hash 0 to 3 range. So in that case, 0 to 3, the grant will be high. After that, it will be low. That's how it is. Because both are like having same format of writing. Only the
Yes.
range is different.
Yes. Here
So,
we know the upper limit range 3. If we don't know, like if you want to check this grant signal up to till your end of your simulation, then you can use here dollar symbol. Okay.
yes, ma'am, that's understood. But in this, the grant is high only after the 3 clock cycles, right?
No, from grant will be asserted high from 0
From 0
clock
to,
cycles.
okay.
Okay, in between 0 to 3 clock cycles, your grant will be high. After your request asserted from 0 to, like how it would be is like, so let's assume like this. So your request is asserted here. Okay. Your grant we have mentioned, it's like double hash 0 lower limit. It means like, so from double hash 0 to double hash 3, you can go. It means in the same clock cycle, your grant should be high for continuously 3 clock cycles. And only the up to that range, it should be high. After that, it should go low. After your request is asserted, your grant signal should be high within the range 0 to 3 clock cycles.
Okay, ma'am.
Okay.
Yeah, understood.
So in the same way, so if you don't know the upper limit, so then you can use this dollar operator. Okay. So from $1 to dollar of grant, when your request is asserted high, so a double hash 1 here, it was starting from 1 clock cycle delay. So when it was asserted high in this thing, so after 1 clock cycle delay only, your grant will be asserted. So it will be your 0th clock cycle. This is your first clock cycle. So grant will be asserted from 1 clock cycle until to the end of your simulation, because we are not knowing any upper limit value here. That's why we were using dollar symbol. Clear? Neha, is it?
Yes, ma'am.
Everybody?
Yes, ma'am.
Okay. So the next set of operators are like repetition operators. As I already said you, like by seeing those the symbols. So we have in the repetition operators. So it means, what does repetition operator means? Basically, by seeing the name itself, we can say we want to repeat a sequence of events. For a certain amount of time, we want to repeat that sequence of events. So for that thing, you were using this repetition operators. Okay. So the symbol is like this. So you are having 3 types of repetition operators. Those are consecutive repetition operator. This is the symbol for consecutive repetition operator. This is the symbol for non-consecutive repetition operator, and this is the symbol for go-to repetition operator. Okay. So after the symbol star, you have to give any number of times, like n. The n value you have to give. So n should be greater than 0 or equal to 0, but it should not contain any negative values, and n cannot be equal to dollar operator. Means you can't check these conditions. Means in repetition operators, you can't use dollar operator. Okay. And what are this consecutive, non-consecutive, and go to? We'll see. Okay. So consecutive repetition operator, so is to specify that a signal or a sequence will match continuously for number of clocks specified. So continuously, consecutive means here you have to remember it was checking continuously. Okay. So it can be either a single number or a range of values also, you can check it. Okay. So syntax is like this: signal asterisk n. N is number of repetitions. How many number of repetitions you want to give, that many. Or inside a property, you can instantiate the sequence. You can call a sequence. Okay. For that sequence, here you have to write your sequence name. And if you want to repeat that particular sequence for n number of times continuously, then you can use like this also. For a signal also you can use. For a sequence also you can use. Okay. So this is like the example. So this is your sequence. At positive edge of a clock, your A should be high. It means by observing this thing, when your A is 1, in the next clock cycle, after 1 clock cycle, your B should be continuously high from 2 to 5 clock cycles. So it means like B must be true for minimum 2 consecutive cycles and maximum 5 consecutive cycles. Okay, so from 2 to 5 clock cycles, here B should be high. After that, it will go to low. Okay, consecutive means continuously. So if you see, when your A is asserted high, after 1 clock cycle, after double hash 1 means after 1 clock cycle, your B should be high minimum 2 to 5 clock cycles. So either for 2 clock cycles, it should be continuously high minimum. And maximum it should be high for 5 clock cycles. So up to here, it should be high up to here. And after that, it will go low. It means continuously it should be high between the range. Clear, everybody? Consecutive repetition operator.
Yes, ma'am.
Next, we are checking for go to repetition operator. So this is the symbol for go to repetition operator. Remember this thing. So go to repetition operator is nothing but here you are not checking a particular signal to be continuously high for a certain range. It can be intermittent also. Means in between it can go low also. Here if you see, here it should be continuously high for 2 to 5 clock cycles. Minimum 2 clock cycles it should be high and maximum 5 clock cycles it should be high. That too it's like continuous. So that's why you are getting like this. Whereas if you use go to repetition operator, here what means like the signal, it should not be mandatorily, it should not be high continuously. It can be like intermittent also. For initially 2 clock cycles, it will be high and after some time again, it will be high. So it would be like that by using go to repetition operator. Okay. So that an expression will match the number of times specified, not necessarily on continuous clock cycle. So continuously, it's not mandatory for go to repetition operator. The matches can be intermittent. Okay. But the main requirement is like, what is like the last match on the expression checked for repetition should happen in the clock cycle before the end of entire sequence matching. So what does this means is like, you will be having like by using go to repetition operator, it is like A should be high for 3 times. Okay, so this is 3 times. It should not be continuously. Anywhere in your entire simulation, your A should be high only for 3 times. Okay, so this last match, when your entire sequence is about to end, so in that A should be high before the your sequence is high. Means when your sequence is going to end, let's say like your sequence is going to end in this clock cycle. So in this clock cycle, your A should be high compulsorily. Okay. So here the sequence will get end. In this clock, your sequence will get end. So before that, your signal should be like high. By using this go to repetition operator, what is the signal associated with it? The last match. The third time A should be high before the end of sequence. Okay. Clear?
Explain this one. Go to operator.
Sorry.
Explain this once again, ma'am. Like go to operator.
Go to operator is nothing but it's not like checking continuously. Okay. Signal should not be continuously high. The matches can be intermittent. Whereas for your consecutive repetition operator, what it was saying, it should be high continuously. Whereas like what do you mean by like non-consecutive? Opposite of consecutive, right? Hello.
Yes, ma'am. Yes, ma'am.
You understood what is consecutive?
Yes, ma'am. Frequently.
Not frequently. Frequently again it will change. It should be continuous. Frequently
Okay, continue.
it would be like sometimes it may be high, sometimes it may be low. It would be like that much frequently. But whereas like continuous, it should be like high continuously. Consecutive means continuously. Coming to non-consecutive, what does it mean?
We can find some discontinuities.
Discontinuities, we can find it. So in the similar way, non-consecutive means we can find some discontinuous in our signal. Same applies for your go to repetition operator also. But the only difference between go to repetition operator and your non-consecutive repetition operator is this line. Okay. Last match on the expression checked for repetition. So last match on the expression checked for repetition means here what is your repetition expression? A go to operator you are using and you are using 3. So what does it mean? A should be high Not continuously 3 times. Means your A should be high for 3 times. It should not be continuous, right?
Yes.
So in this last match means already 2 times your A was high. The last match means third time your A should be high. So the third time then A should be high is depending on the, it should happen in the clock cycle before the end of entire sequence matching. So it means like let's consider that in this clock cycle your entire sequence was matching. Okay, by this clock cycle your entire sequence was completed. In that before this entire sequence was completed, in the before clock cycle, the last time the condition where A should be high, means if for third time A should be high, that condition it should occur here before the entire sequence was over.
Okay, ma'am.
Okay. Whereas going to non-consecutive repetition operator, there is nothing such condition like last match should be the expression checked for this. This is not there. It was only valid for go to repetition operator. This is the only change or only difference between your go to repetition operator and non-consecutive repetition operator. Okay, here the last match should be done before the end of sequence matching, whereas there it's not mandatory. Clear?
Yes.
Everybody clear, or do you want me to explain in a different way also? If you are clear, I can go with the other topic. Come on, speak up. Is everybody clear? At least give me acknowledgement so that I'll get to know whether you people understood or not.
Yes.
Okay. So this is go to repetition operator. So this was the condition. So that's why I have kept in bold thing so that you people can look into it. Okay. So the syntax, we have to use this operator symbol when you want to use go to repetition operator. Okay. So this is the one. In this way you can write it. So what does this means? Like when your start is 0, negation of start you have mentioned, right?
Ma'am.
Okay, so this is go to repetition operator. When your start is 0 after 2 clock cycles, so your A should be high, not continuously for 3 times. It can be intermittent. After like when your A is high for 3 times, after the third time, after 1 clock cycle, your stop signal should be high. So it was like that. Okay. So that is go to repetition operator. And the non-consecutive repetition operator is also like similar to go to, except that it does not require, make this one as bold. It does not require that last match on the signal repetition happen in the clock cycle before the end of entire sequence matching. So here you don't have any such condition. Only this condition is applicable only to the go to repetition operator. Okay. So here the symbol for non-consecutive repetition operator is like equal to n. How many times you have to, like, you can either give here range or a single number also you can give it. Okay. Clear everybody up to here? Consecutive, go to, non-consecutive. Okay. So and construct, we can use and construct in sequence. So what does this is like? Here, suppose let's say you are having two sequences. So those two sequences you are writing inside a property. As I already said, sequences and Boolean expressions are building blocks for your properties. So this is your property, how you write your property. So in this, you can simply call your sequence. See here, I have a sequence S1 and I have a sequence S2. I'm using n construct. Okay. For two sequences, I'm using n construct. So what does it means? Like both sequences must have same starting point, but they can have different ending points. Okay, so it means like all the both the sequences, it should have same starting point, but the ending points, it can be different. Okay. So by using this, like you can also combine sequences by using this AND construct. Clear? And the final property will be like a pass when both sequence succeed, because it's an AND. In AND, if both inputs are high only, you'll get the output. If any one of the input was 0, you'll get output as 0 only. So here also the same. So if any of this sequence was fail, your property will get failed. So it means like both sequence should succeed, then only your property will succeed. Clear? So similarly, you have OR construct also. So OR construct are also same like this, but the thing is like here OR means like normal OR gate, how it performs. If any of the input was high, you will get the output. So similarly here also, if any of the sequence is succeeded, then your property will get succeed. So that thing. And as in the OR construct, if you are using sequences S1 and S2, those are two independent sequence. It means like in AND construct, you have like both sequence should have a same starting point and a different ending point. So in OR construct, you don't have like that anything. So these are two independent sequence. It will be like by using OR construct, you were saying that these two sequences are independent to each other. So it does not like having same starting point or same ending point, like that it won't happen. Okay. So this is your OR construct. So the property succeed when any one of the sequence succeeds. So any one of the sequence is succeeded, then your property will pass. Otherwise your property will fail. Okay. And coming to, you have, so what does this intersect construct? This also keyword you will be using like this. So what the difference between here, it would be same as like and only. Intersection means what are the common things, that only will be there. But the difference is like both the sequence need to start at the same time and should be completed at the same time. Okay. So if you are using intersect construct, both sequences should have same starting point and should have same ending point also. Whereas when you are using AND construct, both sequences should have same starting point, but different ending points you can have. Okay. Only the difference between AND and intersect is both sequence should have same ending point also in intersect, whereas in AND construct, they can have different ending points. Okay. So this is your intersect. Coming to first match. First match also you can use. So what does this first match operator? So in this way you can use your first match operator. Okay. So what does this says is like matches only the first of possibly multiple matches. Remaining matches are discarded. Let's say means like so here if you observe first match of when your T1 is high, after 2 to 5 nanoseconds, like after 2 to 5 clock delays, your TE2 should be high. Means minimum 2 clock cycles, it should be like high. So for the second clock cycle only, if your TE2 is high, then only this first match will occur. Means it will only consider this minimum 2 clock cycles TE should be high. So after completing the 2 clock cycles of TE highness, so this first match will only consider that one, and the remaining all matches it will be discarded. Okay. Clear? Or you have any doubt in this first match? Come on, speak up. Here, let's take this example. Okay. So here, forget about this. I'll just write a condition here. Wait. So that people can. So your A is high. Normal delay. Okay. Normal delay. I'm not using anything. Your B should be high. So this is your expression. Okay. So you are writing here. So when your A is high, so it means like B should be like 2 to 5 clock cycles. It should be high. So when B is high for continuously 2 clock cycles, means up to here. Means when B is high, like up to here. So this comes under your 2 clock cycle. So when you are writing first match of this condition, so it will check when A is high, B should be high between 2 to 5 clock cycles. So when B is high for minimum 2 clock cycles, so it will consider this. Up to here it will consider, and remaining if it is high or if it is low, it will not consider also. It will be discarded. The remaining things it will be discarded. Okay. So it will just check only for the first condition, that is first match. So whenever your A is high, minimum 2 clock cycles, if your B is high, then it will consider this thing and it will say that complete sequence was a pass. Okay, it will discard the remaining thing. So this is called first match. Clear? Now clear everybody? Come on, at least speak up. I'll get to know. See, if you're not asking anything, whenever you're having doubts, later you can't reach to me also. That's why. Okay, so this is throughout. You can use throughout keyword also. So what does this throughout means is like to make certain condition holds true during the evaluation of entire sequence. Throughout operator should be used. Throughout means for a particular time you were just making that signal should be high or should be true. Okay, so the syntax is it was a simple syntax only, so you can just see. Ignore this $fl and everything, we'll get to know later. So here this was one condition, and throughout after that this condition was there. Okay, so here what is like your burst mode should be low throughout the entire operation. Okay, whatever the operation or the expression we have mentioned here, your burst underscore mode signal should be 0 throughout this expression. Okay, the evaluating of your expression, your burst underscore mode signal should be low. That's what throughout means. Clear? Clear what is throughout? Next, within. Okay, what does within is like? You can have simply like if you are having sequence 1, 2 different sequences, so you can use the sequence 1 within sequence 2, or you can use directly like this also. So when your read should be high, with like it should not be high continuously for 8 clock cycles, it can be intermittent. Within this expression, your read should be high for 8 times. Okay, so it would be like this. And if you're using for sequence like this, like for if you're using between two sequences, sequence 1 within sequence 2, what does this means is like sequence 1 happens within the start and completion of sequence. That's what, right? Here also we have seen. So your read should be high for 8 clock cycles within this expression. So until like the evaluation of expression, in that evaluation of expression only, your read should be high 8 times. That's it. Okay, clear? Everybody up to here? Having any doubts? Okay. So this is within we have discussed. So we have like some built-in system functions we have for assertions. Okay, so assertions will provide some built-in functions to check for most common design conditions. Okay, so those are like $1 hot, $1 hot 0, dollar is unknown, dollar count once. Okay. Okay, I'll explain you what are these things. I'll share a new meeting ID. Please join in there. Okay.